Hey guys, welcome back to the podcast. My guest today is Dr. Martin Gibala. He's a professor and the Faculty of Science Research Chair in Integrative Exercise Physiology in McMaster University, which is in Hamilton, Ontario, Canada. His research examines the mechanistic basis of exercise responses in humans and impacts on health and performance. He regularly publishes in peer-reviewed journals and speaks at scientific meetings. He runs an exercise physiology lab that's internationally recognized for research on interval training, and his first study in 2005 generated headlines worldwide. In 2017, he co-authored a best-selling book, The 1 Minute Workout: Science Shows a Way to Get Fit That's Smarter, Faster, and Shorter. Now, this book translates the science of time-efficient exercise for health and fitness and is geared towards solving the number one obstacle to developing and improving cardiorespiratory fitness, which is time. I wanted to talk to Dr. Gibala because not only is he a world leader in exercise physiology research and interval training specifically, but because I wanted his insights in how we take this body of research literature and bring it down to the level of working with metabolically compromised patients that we typically see in the world of functional medicine. I think you'll find his insights pretty amazing. Hey guys, welcome back. It is the Func Med Nation podcast. I'm your host, Dr. Steve Noseworthy. Tremendous pleasure today to talk to Dr. Marty Gibala. As you heard in the introduction, he's quite well credentialed. I would imagine at this point, Marty, you've published. I did a PubMed search just with your name, and it came back with 165 different hits. And of course, I'd have to comb through all of those to make sure that was, the MJ Gibala that usually shows up on your papers. But where do you stand now in terms of your total publications?
Yeah, that's a reasonable number. Depends if you count original articles, journal articles, but probably upwards of 200 publications with book chapters and things like that. But original journal articles, probably 150 or so. So that's fair. I think there's one other M Gibala out there.
Oh, is there really?
But
yeah.
Most of those are mine.
Yeah, there you go. So I do have one question before we get into the nitty gritty stuff, and that is whether or not, I've listened to a couple of podcasts that you've done with other people over the years, and I came away with the impression somewhere along the way that a lot of the research that you've done, or at least the direction that you took your research, was kind of an outgrowth of your own interest in maintaining your own fitness while you were doing your PhD. Is that true, or is that a little bit of a stretch?
No, that's fair. And certainly when I was first a faculty member at McMaster, so I was hired, I've been a faculty member at McMaster for almost 25 years. And so when I was first out of graduate school and my postdoc, you're new to the job, you're teaching courses, you're setting up a research program. My spouse and I had 2 young boys at the time.
Right.
And so it's a busy time of life. And
yes.
So ironically, for a professor of exercise physiology, I found myself with not a lot of time to exercise. And that led to both what I call a personal and professional interest in interval training. I've found it to be quite an effective way to maintain fitness. And my students were often interested in the training regimes of elite athletes. And so
Right.
I would ask them, why does sprinting make you a better endurance athlete? And that led to a conversation of biochemistry. And so the more I'm in this field, the more I appreciate both the scientific and athletic history of interval training. And in some ways, we rediscover it every decade or so, and sort of add a few new things. But, sometimes I'm referred to as the guru of interval training, and I'm very uncomfortable with that because, athletes have been doing this and winning gold medals since the turn of the century.
Sure. It's interesting you say that. I grew up in Newfoundland, and I did my first undergraduate degree was at Memorial there, and I played volleyball. I played volleyball there, and I actually went to Halifax and played for Dalhousie we're talking back in the 80s, right? So we're talking about a long time ago. And I remember the coach that we had at Memorial, and, Newfoundland is somewhat disconnected from the mainland, and growing up, we always kind of thought that we were about 10 years behind the rest of the country in pretty much everything. But our coach, Keith Taylor, God rest his soul, he said one day, he said, next time you guys to come to practice, bring your swim clothes. And we're like, okay, what's going on here? And so he brought us into the pool and he called it Russian step training. And so we basically went into the pool and we did intervals of, really fast treading water interspersed with rest intervals. And I'm a horrible swimmer. I mean, it was absolute torture for me, absolute torture. And in retrospect, and it came to my mind when I read your book back not long after it came out. And by the way, I remember in the book, now that you say it, I think you tell the story of being young, having young kids, and trying to find the time to keep your fitness up. But I thought it was pretty amazing that, kind of in a little backwater university in the east coast of Canada, that a coach who really didn't have all that much training and certification himself was bringing this kind of conditioning into basically an Atlantic Conference volleyball team. I mean, it was just, in retrospect, it was pretty insightful. Anyways, I just thought that was an interesting anecdote. So let's just kind of frame the context, because to be honest, I would love to take this entire time and have you advise me on my own training. That would be horribly selfish of me, but it's really what I want to do. But the audience for the podcast is predominantly functional medicine practitioners who quite often deal with people who are metabolically compromised. And so it's one thing for the average person to pick up your book, The 1 Minute Workout, and to follow your advice and follow your guidelines. But a lot of the people that I and others like me work with have, they're sedentary, but not only are they sedentary, they have very low exercise tolerance. And, we can theorize that part of the problem is the inflammatory cascade, the oxidative stress, the impact on mitochondrial function. So I think ultimately where I would love to go with the conversation is for us to have a sense of how to take the concepts that you've researched and really proven out through your research and tailor that to a subset of the general population that has specific needs. Now, I know that a lot of the work you've done is not necessarily just college athletes or elite athletes. Sometimes you work with people who are metabolically compromised, whether it's a type 2 diabetic or just somebody who's obese with cardiometabolic issues. And I'm going off on a monologue because I've got so much in my head that I want to ask you about. Let me cone it down to this. If we can break this up into different sections, let's talk about the basics, maybe, start with terminology, VO2 max and all that kind of stuff. I do want to talk at some point about the molecular adaptations that happen with high intensity interval training, because if there's anything that we as clinicians probably need to start harnessing, it's that, but we have to do it in a way that doesn't cause more problems than we're trying to fix. That's my concern as a clinician. So if we can kind of go through the science first and then talk about what you found in research and what applies to the general population, and then maybe we can narrow it down to, the unique needs of the functional medicine community. Is that okay with you? And can you wrap your head around that?
Yeah, absolutely, and entirely fair. And you noted about swimming. I was a triathlete, and I was also a very bad swimmer. And so I used to say that swimming was always interval training for me. A couple lengths, stop, up and off a bit. That outline sounds great. From my outset for me, so I'm a PhD, not an MD or a clinician, otherwise, certified. And so I take a scientific lens to this. Obviously, I try to read widely, and including, for my book, as you would know, thanks for the plug, we interviewed a number. When I say we, it was co-authored by a friend and journalist colleague, Christopher Shogan. We interviewed a number of expert medical professionals and other clinicians, including some of those who are involved in physical activity guidelines. The question often comes up, why isn't interval training per se in the physical activity guidelines? And also, as you note, some of our work has looked at individuals with various chronic conditions, cardiometabolic disease, and, obviously a lot of others have contributed to this work as well. So happy to go with that template and whatever you would like to cover in the time that we have available.
Yeah, so let's just start with defining cardiorespiratory fitness, and then get into topics like VO2 max, what it is, how we measure it, I know that you have a sophisticated lab with lots of sophisticated equipment that we don't have. So somewhere along the way, some insights into how does a how does a clinician like me who doesn't have access to that, or at least not easy access, how do I get a handle on someone's VO2 max? So let's back up and let's just start cardiorespiratory fitness. What is VO2 max? And then we can kind of branch out from that point.
For sure. So cardiorespiratory fitness is the integrated capacity of the cardiovascular, the respiratory, the skeletal muscular systems to take up and utilize oxygen.
Yeah.
So the best objective measure of cardiorespiratory fitness is a maximal oxygen uptake test. And of course, this would be a progressive ramp test, often on either a cycle ergometer or a treadmill, most commonly, not unlike an exercise stress test, taking the stress test to the functional limit of the individual, while oxygen uptake is measured directly at the mouth.
Right.
And VO2 max is a common term that athletes are aware of, but as I stated, it's the best objective measure of cardiorespiratory fitness as well. You know, we measure it in the lab using some sophisticated equipment, metabolic carts, but it can be estimated as well. And so there are non-exercise algorithms or calculators that are out there. Of course, you could Google these and find them on the internet, but I would direct your listeners to, if they just Google world fitness level, and an online calculator will come up that is the best calculator out there. It's validated, and it's based on extensive data that's been collected in Norway. The primary researcher there is Ulrich Wisloff, who's done a lot of studies. And so even though, and what you would have to do if you go to the calculator, input some numbers such as your age, your biological sex, some, rough estimates of your typical fitness. You know, are you completely sedentary? Do you a little bit?
Right.
And it will give you a number. And even if the number is not entirely valid or accurate, it's a pretty good number to look at changes over time. So Are you trending positive? Are you trending negative? And then the intermediate between just an online calculator and having it measured in our lab would be there's lots of submaximal field tests out there. You know, a classic one is the Canadian home fitness test, where you would just step up and down on a single bench step to a metronome and measure your pulse, which you could do just by feeling your neck or your wrist. And based on your pulse, that's going to give you, then you refer to a nomogram, that's going to give you an estimate. There's beep tests, shuttle runs, so many different ways to look at this.
So and I'm thinking clinically here and practically, if we use that website and that calculator that you say is a validated algorithm, how closely does that match what you do in the lab? And is the correlation more accurate or tighter for certain populations, whether it's elite athletes or sedentary people?
So certainly it's validated and correlated. And again, we don't have to belabor it here, but at the site of the calculator, an interested individual could go into what is the science behind some of this, and they could look at the scientific research that backs up the calculator. I frankly don't know if it would be any better for a highly trained athlete compared to a sedentary individual, because it really comes down to these 6 or 7 basic questions. And I would suspect that, typically people on either ends of the far tail, it's maybe less accurate. You just think about a normal distribution. Most people are going to fall in the middle. And so it's probably going to capture, again, most accurately those. But, we've in many of our research participants, we're measuring objectively VO2 max, and then we'll have them refer to the calculator. And again, our ad hoc or subjective impression of that, without doing a scientific study, is it's not bad. It's certainly reasonable if that's all you have available.
Right.
And let me just emphasize as well, why is cardiorespiratory fitness so important? Well, clinically, there's been strong calls that it should be clinical vital sign that we measure along with things like body temperature and blood pressure.
Totally agree.
Because again, as many of your listeners, I'm sure, would be aware, individuals who have a 1 MET higher cardiorespiratory fitness, so that's maybe a 10% higher value for the average person, your all-cause mortality risk is 15% lower. Your risk of developing cardiovascular disease is about 19% lower. And so it's just such an important metric, but it's not typically something we assess in a clinician's office.
Yeah, and I'll tell you, just maybe for some context for you, but certainly for anyone listening, like in the field of functional medicine, you have credentialed practitioners, like myself, chiropractors, we have medical doctors, nurse practitioners, DOs, oriental medical doctors, and naturopaths, and then we can get into things like dietitians and nutritionists. And obviously we all have different backgrounds from education and experience, and everyone practices functional medicine kind of in their own way, right? There's no universal governing body that says this is what functional medicine is and this is how you should do it. And so the circles that I run in particularly when we teach weekend seminars, we teach a clinical model that places tissue perfusion and oxygenation at the top of the list. Like that's the base of your hierarchy, that if you can't perfuse your tissues, if you can't deliver oxygen to your cells to drive ATP production through oxidative phosphorylation, then you're not going to get much else in different places because of the importance of ATP, just for general physiological function. And to me, well, you said that you think that this should be another vital sign. I cannot agree any more wholeheartedly than I do for that particular reason, which is why I think it's important for us in the field to be able to assess it without necessarily having access to like an exercise phys lab like you run. And so I'm glad to hear that we do have some options, but it begs questions to me. Like, for example, we're in the age of wearables right now. So I've got my iWatch, and it, if I go for a walk with my wife, or so you got an Oura ring. So I look at the VO2 max that's estimated in my health app on my phone and with my watch. And I've been to the website that you referenced, and I've put all my data in, and there's like a 10-point difference between what my watch tells me and what the calculator tells me. So where are we in terms of wearables? And are all wearables off to a certain point, or there's something like the Oura ring, for example? And I'm asking because you're wearing one. Like, which one rises to the top in terms of accuracy?
Yeah, so I don't have an expert opinion on this. My general opinion is all of the wearables have limitations. My understanding is it really depends, obviously, on the underlying algorithms, which vary.
Sure.
My own experience with a number of wearables is they're not particularly great at even measuring heart rate, particularly at high intensity or intermittent exercises. It just doesn't capture it well compared to, for example, if I wear a polar heart rate strap and measure it that way. And so the corresponding numbers that are invariably generated are not necessarily great either. But so I would say, my sense is the validity of some of these is not great, but probably like a lot of things, they're reasonably reproducible. And so again, regardless of what the actual number is, probably people shouldn't trust the number as being fully accurate. They should rather use it as a guide point, again, for this idea of trending positive or negative, or looking at changes over time. The reason I purchased an Oura is, again, based on my reading, it's one of the best devices out there for tracking sleep. And so, I'm a committed exerciser. Yep. I know what my VO2 max is. Yep. I'm going to do this. I don't need external validation or encouragement. But one thing that I'm trying to do, especially as I age, is sleep better. Yeah. And I get very objective data that helps me. Although most of the time, if I haven't slept well, I know it, and the Oura ring just reinforces that. And my friend and colleague, Dr. Stuart Phillips at McMaster, I know he ended up just abandoning all of this because all it did was reinforce that he's not a particularly great sleeper a lot of times.
And I wonder what we did before all the wearables hit the market, right? I think about working out 15, 20 years ago. It's like, when you were pushing yourself hard, when you needed to stop and take a rest, and generally when you were recovered enough to go again. And, now we're kind of tied to the numbers. And constantly checking my heart rate, go, okay, now I'm down to a certain threshold, it's time to go. So I completely hear you on that. So with the wearables, do they tend to consistently under or overestimate VO2 max?
I think it goes both ways. And again, I haven't done a deep dive in this, but just my general sense
Right.
is that it can over or underestimate, certainly depending on the device and maybe even in the given situation, right? So are you engaged in high intensity exercise or not? And let me bookend that statement with saying, I also involved in some collaborative research. This is not led from my group. This is led out of an individual, Emmanuel Stamatakis at the University of Sydney, where we recently published a paper where we were harnessing the power of wearables, and it was data that was collected as part of the UK Biobank. And in that study, in large numbers, over 25,000 individuals who had worn wearable devices, we were able to track mortality risk over a 7-year period and show that engaging in brief, vigorous, intermittent lifestyle activity, something we've termed VILPA, even 3 to 4 bouts of vigorous effort, 3 to 4 bouts totaling 3 to 4 minutes of vigorous intensity physical activity, not even structured exercise, was associated with a marked reduction in all-cause mortality. We're talking almost 40% and even higher when it came to cardiovascular disease risk. So, I think that's an example of where wearables can really be harnessed in a research setting. And from an applied or practical, one of the things that we called for or suggested is maybe we can, build in greater motivational tools, tracking your VILPA as part of your Fitbit or name your device to encourage people. And it fits with this overarching theme where small amounts of physical activity can pay a lot of benefit. And if you don't have a half hour in your day, some people tend to blow off their exercise, and people who are just starting out, compromised, as you say, I think that's an empowering or encouraging message for them that, hey, even 30 seconds at a time can really pay benefits if it means a couple of minutes in a day.
Yeah, and I know that in the book, and it's been a while since I've read the book, but if I remember correctly, you talk about the concept of exercise snacking. And before we get into that, can you define again VILPA? What does VILPA stand for?
Yeah, sure. So VILPA stands for vigorous, intermittent, lifestyle physical activity. And so the key things there are vigorous pace, intermittent in nature, lifestyle physical activity. So this is not structured exercise. We're talking about things, activities of daily living that you might already be engaged in. You get off the bus or the subway and you're heading home and you have your groceries or a heavy backpack and you pick up the pace. These very simple cues and messages that we give to people. One of my favorites, of course, you get off the airplane, the plane, you've been sedentary for 5, 6, sometimes 8, 10, 12 hours, and you have the choice between the escalator or the stairs. Obviously, the best thing is to grab your bag. You have, weighted uphill stair climbing.
There you go.
Is a classic example of VILPA, but many of us choose the escalator, of course. So it's taking advantage of those opportunities that are already part of our day, regardless of building in structured exercise.
So I was just thinking, let's delay the conversation about exercise snacking, because I do think that that's probably a great way to start somebody who is metabolically compromised on some type of interval training. And, I would imagine that for the most practitioners who are listening, we tend to shy away from asking people who are metabolically compromised to do things that are relatively intense. And so let's go back to kind of like the basic science. What are some of the molecular adaptations? Like, we understand that there's an increase in efficiency in oxygen uptake and delivery, right? And that's clinically, that's what we're looking for. But I know that you guys have studied, at least in some ways, the molecular adaptations as it relates to changes in heart muscle and function, changes in muscle fiber when you do your tissue biopsies. and also changes in mitochondrial biogenesis, which for us, that's probably where the gold is. So can we talk a little bit about these molecular adaptations so that if a clinician says, hey, I'm going to start implementing this, what is it that they can expect clinically? And, how do we communicate that or the importance of that to someone who's going to be doing that activity?
Absolutely. And if you indulge me, just before we get to that discussion, even taking this step back around interval training, and you'll see I continue to use that term as opposed to high intensity or HIIT. HIIT, that's sort of the buzzword, and that captures a lot of the headlines. And to me, that's one specific type of interval training. And I think, an unfortunate reality of the field still is there's no universal terminology or accepted definition of HIIT. Many offer them. So for me, I like this more encompassing term, interval exercise or interval training, which is just intermittent. Go hard, take a break, however you define that. And I like to think of it in terms of green, yellow, and red zones. If you're an athlete, you're often talking about 3-zone training or 5-zone training. But if we could just think of 3 zones, whereas green is intermittent, light to moderate exercise. And so that might just be interval walking for some people. Yellow zone is vigorous but submaximal. So somewhere around about 80% of maximal heart rate up to about VO2 max pace. And that's where classic high intensity interval training would fall. And then we have red zone, which is true supramaximal or above VO2 max pace, right up to sort of sprint from danger or sprint to save your life pace. Right. And obviously we can perform at a workload that's well above VO2 max pace for very short periods of time. And so it goes back to this issue of, can people perform interval training? In my opinion, almost anyone can. Clearly there's certain individuals for whom exercise or interval training is absolutely contraindicated.
Yep.
But if we're talking green zone intermittent type exercise, there's great data on older individuals with type 2 diabetes who are overweight and clinically obese being able to perform that type of exercise. And actually it might provide great benefits in terms of blood sugar control compared to just steady state walking. Both options are great, but there are some data to suggest that the intermittent approach, even what I call gentle hills and valleys, just varying up the pace, may provide better returns for a given time investment.
Yeah, and just for clarity, you mentioned you used the term interval walking. That doesn't mean walking sometimes. That means while you're walking, varying the pace for a given time and then slowing down again. And you can accomplish that on a treadmill or just out walking in your community, right?
Absolutely. Our classic example was always, if you're walking your dog or with a partner or your spouse in the evening, pick up the pace for 2 light posts and then back it off. And as simple as that sounds, there's good data now from small, well-controlled randomized clinical trials to support the point that I just made around fitness, even body composition, and certainly blood sugar control.
Yeah. So let's get back to the molecular adaptations. And dude, every word that comes out of your mouth makes 5 more questions pop into my head. So let's go back to the metabolic adaptations and let's kind of talk about that briefly. We don't have to go into too much depth and detail unless you want to expound perhaps on the mitochondrial biogenesis aspect of that.
Sure. So, I'm trained as a skeletal muscle physiologist, and so much of my basic science research looks at skeletal muscle remodeling and how exercise dose, volume, intensity, duration affect that process. And the process that we study the most is indeed mitochondrial remodeling. And so mitochondrial biogenesis, of course, is just the formation of new mitochondria. And of course, many of us, we were trained to think that mitochondria are these bean-shaped compounds, but really they're a reticular network, much like a capillary. So you can imagine capillaries flowing through skeletal muscle. The mitochondrial reticulum is very much the same, but we can quantify changes in the mitochondria either acutely, so we can study this process of biogenesis, so the triggering process, by looking at certain molecular proteins. So we can study, for example, the phosphorylation of specific proteins using various blotting techniques. We can use, RT-PCR to look at changes in mRNA levels. And so those studies would be very acute, where we give someone a dose of exercise, we take a biopsy from their skeletal muscle before and either right after exercise or a few hours into recovery, and we can literally quantify or measure the turning on of these various signals. And we know that these signaling cascades are then in turn linked to functional and other changes in mitochondria. So either the structure or function of mitochondria. And there's certain key ones that you'll look at. So PGC1 alpha, for example, is a very important regulator. Some people refer to as the master regulator of mitochondrial biogenesis. If that's activated, you're going to get new mitochondria formed. So that's the way we generally study it. And you can sort of think of some of these other proteins as serving as molecular fuel gauges. And so as the fuel availability in the cell starts to drop, glycogen availability or things like that, the fuel gauges are starting to fall. And so you can imagine it's like the red light on your dashboard coming on, and intensity of the red light might signal the relative energetic crisis. And so even though, from elegant studies, most of it in animals, we know that activation of these molecular fuel gauges is important for triggering biogenesis, but we don't really know, well, is it the rate that they're turned on? Is it the absolute amount that they're turned on? Is it a threshold that you have to get to? And so that's what a lot of the human research is now trying to tease out. How can you do these short, quick pulses? And so our sort of working hypothesis is, you can imagine you could push on the gas pedal in your car and hold a given moderate speed for a long time, and that's going to run out of fuel. Or you can reef down on the gas pedal really hard and drop the rate of fuel quickly, even though it's going to be a smaller magnitude of change, absolutely, but the rate of change is very high. And what it appears is that we can turn on the same molecular restructuring process or physiological remodeling process in different ways. So it's not that there's anything particularly unique about interval training in terms of the underlying physiological responses. It's just that you're triggering that same fundamental biological process in different ways, or at least that's how we think about it, and have some evidence to support that.
So are we at a place right now where we're questioning, and if I heard what you said correctly, questioning whether or not improvements in function are due to increased number or increased function of the mitochondria? Do you ever see in your studies, function improving, but mitochondrial population doesn't change?
Less so to that. So you can measure improvements in both content and function, but if you express the improvement in function relative to the increase in content, the intrinsic capacity of the mitochondria is not getting much better, if you will. The qualifier there would be in some compromised individuals or certain disease conditions. And again, I am not expert here, but my colleague, for example, Dr. Mark Tarnopolsky, who's a clinician scientist, he's a neurologist who studies mitochondrial disorders. And Mark has done a lot of work looking at both nutritional as well as exercise interventions in these patients, many of whom, these are very rare mitochondrial disorders, often affecting very young children. And so my sense there is you can see changes in intrinsic capacity sometimes, but generally speaking, I think in healthy humans or even compromised humans, the improvement that we see in functional capacity is mainly related to an increase in content, and so overall function, as opposed to intrinsic mitochondrial function on a per unit basis.
Yeah, understood. Have you, and it's interesting that you brought up your colleague, because my next question was whether or not you guys had ever studied as part of an intervention using nutrients, natural compounds that have been shown to improve either biogenesis or or oxidative phosphorylation and cell respiration. So whether that's antioxidants or membrane phospholipids like phosphatidylcholine, anything like that, have you done different cohorts where training stimulus was the same and one took supplements and the other one didn't?
Yeah, we have. We've done a number of studies using nutritional interventions to see if we might promote greater responses. And generally, generally we don't see much in that the nutrient doesn't markedly augment things. And that's probably because exercise is such the big hammer. The nutrient, if it's eliciting responses, it's very subtle. If you talk about elite athletes, there's a pyramid, right? And the base is sleep and fundamental nutrition and fundamental training. And then maybe at the top of the pyramid, there's room for very specific nutritional supplements in specific situations. And if you're the elite athlete who's doing everything else perfectly, you can get improvements from that in certain situations. But for most of us, we don't have even if we're committed, we don't have the pyramid that great. And so the variability in the pyramid is just so great that changes in nutrients or that subtle nutrients don't have a major effect, but there is some work, for example, around low carbohydrate availability. I'm not talking necessarily ketogenic diets here or anything like that. And that could be a whole separate podcast because we're doing some work with exogenous ketone supplements, for example.
Okay.
But just low glycogen availability per se, there is some evidence that can enhance mitochondrial biogenesis, probably because it makes exercise more stressful. If you don't have carbohydrate on board, it's a more stressful situation. But it doesn't necessarily mean the performance is going to be better. So it's a bit like altitude. I can take you to altitude and it's going to hurt like heck when you're exercising. It's going to be more stressful. But it doesn't mean that that's going to lead to greater functional responses when you return to sea level. Again, the exception there would be in really compromised patients or certain conditions. And so, for example, again, Dr. Tarnopolsky has used something as simple as creatine, which we know is involved in ATP transfer into the mitochondria and shuttling. Creatine supplementation in some of these individuals has actually enhanced mitochondrial function. So it's like anything in science. It really depends on the context. There's a lot of gray and nuance is really important.
Yeah, understood. So, we've been talking about some of the studies and doing biopsies and looking at tissue-specific adaptations. It brings to mind the question as to how modality-specific these adaptations are. Like, I know that you're a big cyclist. So if I'm a clinician and I'm trying to get someone to get into some kind of an interval training that's appropriate for their physiology, do I need to worry about the modality that we use? If my goal is to improve global and systemic mitochondrial population and function, should I have them bike on one day, row on another one, swim on another one, or do some combination? Or can we pick one modality? Because I know you're very big on maybe the most important variable is adherence and consistency, which means you got to do something you enjoy that you'll stick to. So can you speak to that?
Yes, and I don't mean to start every answer with "it depends," but it does depend. And so I guess, so point number one is if we're talking cardiovascular conditioning, there's an old saying, your heart doesn't know what your muscles are doing. And so from that standpoint, it doesn't matter. So whether you row or swim or take the stairs or cycle or walk uphill, the cardiovascular stress for a given intensity is going to be about the same. So however you elevate your heart rate, you're going to get cardiovascular remodeling. And so the delivery side of the equation, again, if we're comparing a given dose of exercise at a given intensity, is going to be the same or very, very similar.
Right.
And given that cardiorespiratory fitness or VO2 max is primarily limited by delivery, so it's not oxygen utilization, it's more a delivery problem. So that's one answer where it doesn't matter. Now, if you're looking more at mitochondrial remodeling in skeletal muscle, which clearly is a contributor there, and it might be a more important contributor, arguably in certain situations, or for continued submaximal exercise, or the ability to sustain any type of physical activity without fatiguing very, very quickly, the more specific training, the better, right? And so if you want to have the greatest improved mitochondrial content in your vastus lateralis and you're a cyclist, you want to cycle a lot and you want to do a lot of intermittent cycling exercise. And even, we have one of these in our lab now, even single leg cycling, where athletes are doing counterweighted single leg cycling. So it very much resembles and feels like natural two-legged cycling.
Sure.
Well, what it allows you to do is increase the workload that one leg is able to do, because there's not a central delivery problem. So lots of really cool applied settings there.
Yeah.
So again, it's an it depends answer, but it depends in part on, are you targeting more the heart, the lungs, the blood vessels, or are you targeting more skeletal muscle? And then, from a applied perspective or a real life perspective, given that our biggest problem is people are just not moving generally, yes, then I would come back to do what you can get your patient to do, or what they like and enjoy, because they're probably more like to stick with it. And if they're open to variety, variety's always better.
Right. So, and I was thinking a couple of days ago, before this big ice storm came and hit us, I was in the gym. I did about 65 minutes where I did the first 20 minutes on an elliptical, and I was kind of keeping it around the zone 2 stuff. And it was, that particular day was a long, slow intensity day for me. And then, so I get bored very quickly with all this stuff. So I'm not usually listening to podcasts or something. So I'll spend 15 or 20 minutes on, say, an elliptical, and then I'll pop on the rower, and I might spend 5 or 10 minutes there. And then I might go to like an echo bike, like a Schwinn Airdyne type thing. Because for me, I don't play sports anymore. So I don't have the demand of specificity. I want global impacts. And so it brings to mind questions, because I've heard you say in other podcasts, and I've seen this in the literature, about modality-specific adaptations. But, most of our clients, at least the ones I work with, they're not athletes unless you want to call life as a sport, right? So we're all athletes in the sport of life. I look at it that way. And so I want global adaptations. I mean, I don't want to go, okay, your legs are really efficient at doing something, but the rest of your body is not. And I know that there is some carryover with things like even high intensity strength training into VO2 max, but it doesn't come anywhere near the specific adaptations in cardiorespiratory fitness as you would get with either steady state cardio or with intensity work, like high intensity intervals. And so I wonder about things like, I'm a huge kettlebell fan. And if if anyone thinks that you can't get a good cardio workout with kettlebells, let me disabuse you of that notion. I mean, it can be incredibly, incredibly anaerobic, or it can be very low steady state sustained. So would something like either, continuous two-handed kettlebell swings, or doing like a complex of movements where you're constantly moving, you're varying your speed and intensity, but you're still using the same weight, to me, that would be ideally suited to developing some kind of whole body increased efficiency in cardiorespiratory fitness. Would you agree or disagree? And if I'm wrong, where am I wrong?
No, I agree 100%. And, I used to call them pre-pandemic hotel room workouts, right? You get to the gym, and especially if you're traveling in North America, it's impossible to find the stairs, or it's an emergency exit only, and you can't get to the gym. So you have to do something in your hotel room. And invariably it's burpee sets or things like that. And so, I believe, I'm a believer in kettlebells. I have some in my, my home gym in my basement as well. Same thing. So absolutely, resistive type exercise, especially when done at a vigorous pace with short recovery periods, absolutely can provide a cardiovascular conditioning stress. And that's where I think body weight style or simple equipment-based resistance exercise, it sort of op or falls in that sort of great middle zone. And as you say, it's not going to provide the cardiovascular conditioning that traditional endurance aerobic training would. It's not going to provide the strength benefits traditional heavy weightlifting would. But for a lot of people, it doesn't really matter. It's an extremely time efficient way to train. It's extremely functional. You know, again, I'm talking to converted, and you well know this, but you know, it's fine to sit on a bike, but that's not providing a lot of functional strength for you. It's making your quad stronger, and your heart's getting more aerobic. But you know, this was something that, not to get off topic, but it really came home to me. I had a bike crash, and I suffered a concussion, and I was seen by a neurologist. And as part of my recovery, because, you know, I know, okay, exercise is good for fitness, and that can help recovery from concussion if you start slow and all of that. But the neurologist, first thing they said to me is, actually, I'd rather have you just out on the street throwing a Frisbee with someone, you know, and because of sort of the three-dimensional or just go for a walk, ideally on some trails. You know, I was literally wearing a helmet, so there were some precautions there. But in my head was just like, I'm going to get back on the bike at home. And he's like, that's great. That's going to help you. But it was a reminder that functional movement and three-dimensional space is important for all of the adaptations that come along with that.
Yeah. We should get you and Tom and I on and just talk about the value of multimodal exercise and the impact on the brain and all that kind of stuff. That would be a fascinating conversation. Let me go back to something you said about the mitochondria, because the classic way that's taught, at least the way that I learned it, is that you have these individual organelles that are floating around in the cytoplasm. But you said that it's really more of a reticular network. So inside any given cell, you have X number of mitochondria. Are they connected in some contiguous fashion with physical structure, or are they connected biochemically where they're just talking to each other in a network fashion?
Yeah, probably both, but certainly they're connected in a physical structure. And now there's these very elegant 3D imaging studies, including on human muscle, where they're basically able to stain just the mitochondrial network and then sort of take the other stuff away. And it very much looks like a capillary network.
Wow.
And so, you know, we still talk about subsarcolemmal and intermyofibrillar, parts of mitochondria. And we've done electron microscopy analysis in our laboratory, you know, looking at trying to quantify subsarc and intermyofibrillar mitochondria, but recognizing that they're still connected, even though they tend to occupy more, you know, the volume of certain parts of the muscle.
Right.
Subsarcolemmal and, you know, literally squeezed between the actin and myosin filaments is where they sort of reside most inside skeletal muscle. And then there's also probably these very complex biological signals that are also talking, you know, and there's, again, my colleague, Dr. Tarnopolsky, talks about exerkines, which are really just myokines that are released from skeletal muscle, but from other places as well, that, you know, we're just really learning about the interconnectivity of these molecules.
And, you know, on that topic with the myokines, do you think that is at least partly responsible for systemic improvements in health when you're doing modality-specific exercise?
Yeah, I do. And again, I'm biased by interactions with Mark and his thinking on this, but or I've been educated by Mark and his thinking on this. But, you know, certainly, you know, why, you know, how do we explain that, you know, skin is often younger, if you will, in exercisers, you know, even, you know, name a physiological function and there's almost any part of the body that's enhanced by exercise. And it can't just be because that local tissue or cell was engaged. And so it's probably related to, you know, something of these circulating systemic factors that are contributing some enhancement there.
Yeah. All right, let's circle back around because I realized that we didn't talk about in the scheme of measuring VO2 max and using that as a metric of cardiorespiratory fitness. Talk about good numbers, and I can hear you saying, well, it depends. It depends on where you're starting from, I'm sure. You know, any improvement is better, but do we have certain thresholds that if I'm a clinician and now I'm looking at VO2 max as one of the vital signs that I should be tracking or at least assessing initially in my client base, what numbers should I be looking at in terms of minimal capacity? And let's assume we're using the online calculator rather than doing formal testing.
Yeah, no, for sure. And in fact, I teach a second year exercise physiology course. And so our lecture yesterday was on VO2 max. And I talk about what I call reasonable values. And I tell my students, you don't have to memorize an exact number, but you should have a second year kinesiology student should have a reasonable idea of what's a good VO2 max or what's an elite level VO2 max. So that I knew the numbers, of course, but they're particularly front of mind. And so, if you want an authoritative source, you could go to something, for example, like guidelines put out by the American College of Sports Medicine, the ACSM guidelines that would have VO2 max expressed relative to age and various, thresholds or classifications. But, on average, a typical healthy but otherwise sedentary middle-aged individual might have a VO2 max of somewhere around 35, and that's milliliters per kilogram per minute.
Yeah.
And so what we're expressing there, the rate of oxygen uptake in terms of mils of oxygen per minute relative to their body mass. And so it gets across this point that we can all talk about VO2 max in an absolute sense. So someone might have a 2 liter per minute VO2 max or a 4 liter per minute VO2 max. Well, if you divide out their body mass there, that can impact things a lot. So normally when we're talking about cardiorespiratory fitness measures, we're talking about relative measures of VO2 max. And so that means, numbers on a scale that typically range from about 10 to 100. The highest VO2 max ever reported in humans is about 91. It was in an elite gold medal winning cross-country skier. Cross-country skiers of the elite endurance athlete community, cross-country skiers tend to have the highest VO2 maxes. At the other end of the spectrum would be a cardiac patient, highly deconditioned cardiac patient who might have a VO2 max of 10, 12, 15 mils per kilogram per minute. Resting VO2, you may have heard of the concept of a MET, which just refers to the oxygen required, at rest. One metabolic equivalent is 3.5. And so that would be the average resting VO2 in humans. And so there you get a sense, well, a cardiac patient might have a 3 MET capacity, whereas an average individual sedentary maybe has a 10 MET, whereas the elite endurance athlete has, 20, 25 MET capacity. And that it sort of gives you a working operational range from rest to maximal capacity. 3 is not very much.
Right.
And so even, if you're a cardiac patient, getting off the couch and walking a few steps, it's like you're at the top of Everest, right? It's just such a challenge because your peak capacity is 3 or somewhere around 11, 12, 13 mils per kilogram per minute. So those are sort of the range of values. And the ACSM and other authoritative sources would say, well, this value would put you in the 20th percentile or the 50th or the 75th or the 90th. And so often in our research studies, we'll say, we just want people sort of in the middle. Or if we're doing more trained athletes, we'll say, we're only going to recruit individuals who have 90th percentile for age level to try and to get that. But hopefully that's helpful in terms of ranges of values and things like that.
Yeah, it is. And, but, several things come to mind because when you look at the units that VO2 max are expressed in, right? Milliliters per kilogram per minute. And because body mass is part of that equation, you could take somebody with any given VO2 max, and if they're overweight, have them not exercise, do things to decrease their body mass, and their VO2 max will automatically improve. So does that then map over to the concept that if you carry around excess non-functional weight, right? Not an extra 10 pounds of muscle, but an extra 30 pounds of body fat. You think in terms of, like, very simplistically, that's a strain on your heart. Is there metabolic truth to that concept?
Yeah, I'd say there is. And so, to use that specific example, and you're right. If you reduce the denominator, the number is going to go up. And so if an individual loses 10 kilograms or, 25 pounds of body mass, that will significantly improve their cardiorespiratory fitness measured numerically. Now, even though their heart function per se may not have changed,
Yes.
they're still going to have a markedly higher functional capacity, right? Because now if they go for a walk, they're carrying, say, 20% less body to move. And so if you can think of what's happening, the demand to walk at, say, 4 miles an hour is here. They've sort of artificially, if you will, elevated the numerator. And so when you express it now, maybe before walking took them 60% of VO2 max or 8%. Now you've reduced that. It's only a 40% or 60% of maximal load. And that's both perceptually easier for them to achieve, and physiologically, the way that they supply energy at 40 or 60%, they're going to be more reliant on lipid. And so they can burn more lipid if they're engaged in exercise. So ideally you want to do both, or, ideally you want to raise the numerator and reduce the denominator. You can do either. Right. And like I say, I ideally you do both. And it sort of gets back to the old adage where, we engage physical activity for fitness and we use nutrition to regulate body mass, right? They impact on each other.
Yes.
But the two are the big drivers on either extreme.
Yeah. So, and the way that I tend to think about this, and this would be, I guess, a way that I would translate this into patient speak, is that if we can decrease your body mass, your heart and your lungs no longer have to perfuse that extra body mass. And so now you have more resources available to go to your brain, to go to your gut tissue, to go to your liver, to support normal function. I love that. And it was funny because as I was thinking, like, how do I translate this into a mental picture or an analogy? And I was thinking about, we have 5 kids and now they're all grown out of the house and supporting themselves. And so they're off the payroll, so to speak. And all of a sudden now I've got more money to go to, the life and the lifestyle that my wife and I like to have. And I think that that's a pretty apt analogy to capture the core concept. So
it absolutely is. Sorry, I was just going to say, and it comes back to blood flow distribution. Yes. You're right. And so if you need to partition out less to this tissue mass, you got more blood flow to divert elsewhere, and it can go to your skeletal muscle to enhance your physiological function. So it's a very good analogy.
Yeah. I'm watching my time here, Marty, and I am by no means close to being done with the questions that I have. So I don't know how much time you have. Do you want to keep going?
I'm happy to keep rolling. Again, if your audience hasn't tuned out by this time, but I mean, I'm happy to roll for a while yet.
Okay, that's cool.
And if it would be a benefit.
Yeah, absolutely it would. And I might split this up just into 2 different podcasts so people can digest it a little bit more.